Okay, let's dive right into this. Picture a bustling corporate office for a second. You've got phones ringing nonstop, keyboards clacking away, emails flying out the door, and absolutely massive files being downloaded by hundreds of people all at the exact same time. How does all of that digital traffic not just instantly crash into a giant virtual traffic jam? Well, welcome to this explainer. Today, we're demystifying the whole business network. We're going to trace the absolutely fascinating journey of data, starting from a single employee's desk, going all the way out to the global internet, and, best of all, we'll figure out how to troubleshoot the whole thing like a pro. To kick things off, I want you to really ask yourself, why is your office network fundamentally different from your standard home Wi-Fi setup? It's super tempting to think of a corporate network as just, a beefed up, slightly more expensive version of the router sitting in your living room right now. But actually, scratch that. If you're approaching it with that mindset, you are missing the incredible engineering that keeps modern businesses running. We kind of need to completely rethink our assumptions here. Just look at the sheer difference in scale and purpose. At home, you've got your basic connectivity, right? You're streaming a movie, maybe casually browsing the web on your phone. But on the business side, it's a totally different ballgame. We are talking about a robust ecosystem built for massive scale and serious security. A corporate environment has to securely connect hundreds, sometimes even thousands of devices. It's got to let employees share highly sensitive files, print huge documents, and access critical apps without a single hiccup. Honestly, it's an entirely different beast. Okay, so Section 1, the starting point, user devices, and the local hub. Let's get into it. So let's start mapping this out together. Every data trail starts right at the employee's desk. We've got your common user devices, your standard desktops, mobile laptops, VoIP desk phones, and, oh yeah, the perpetually jammed office printer. We rely on physical, stable Ethernet cables for the stationary heavy lifters, like those desktop PCs and phones, while mobile Wi-Fi keeps laptops and smartphones moving freely around the office. But here's the thing. Whether you're clicking print from a laptop in the break room or dialing a client on a desk phone, all of these local devices need a central place to send their initial data. And that brings us to an absolutely vital piece of hardware. We call it the switch. Think of it like the ultimate local traffic controller, or maybe a super efficient internal mailroom. It's amazing, really. If computer A wants to print a quarterly report, that data doesn't actually need to travel all the way out into the global internet and back. No way. Instead, the switch grabs that data and routes it seamlessly and directly to the office printer down the hall. It keeps all of that internal traffic localized, lightning fast, and highly secure. Now let's move to Section 2, Border Security and Gateways, and see how this builds when data actually needs to leave the building. So what if you're accessing a cloud application or emailing a client out of state? Well, the switch isn't enough anymore. Now, the data has to hit the router. The router is your literal border crossing. It's the gateway device that connects your secure internal local area network to external networks, and ultimately, the entire global internet. Literally every single piece of outgoing office data must pass through this specific checkpoint to find its way out into the world. But wait, we can't just let data flow out, and more importantly, flow in, totally uncontrollably, right? Enter the firewall. And this right here brilliantly illustrates the whole corporate security mindset. The firewall is the ultimate security guard, standing shoulder to shoulder with the router. It doesn't just casually wave traffic through. No, it meticulously inspects every single packet of data. It filters traffic based on strict rules, it blocks unauthorized access from hackers, and it stops viruses dead in their tracks. It is scanning absolutely everything at the gate to keep the internal ecosystem safe. It's totally crucial. Now, once your data has been scanned, cleared, and officially approved by the firewall, it jumps onto the physical exit ramp, the telecom service link. Picture a high-speed, glowing fiber optic highway carrying business data right out of the building. We're talking literal glass threads, way thinner than a human hair, transmitting your data at basically the speed of light. They run right out of your office building, usually buried under the street, connecting your corporate setup directly to the telecom provider. This is the heavy-duty pipe carrying all your business data into the outside world. After flying down that telecom link, the data finally hits its destination. And generally speaking, we're looking at two main pathways here. It either hits the public internet, sprawling out to connect to cloud applications and public websites, or for highly sensitive stuff, it goes to private corporate data centers. Those are highly secure, off-site internal servers where a company stores its most protected, proprietary information. Let's pause for just a second. Section 3, the data's journey map. Let's just take a breath and absorb the complete architecture we've mapped out here.
Let's do a brisk recap of how this flows from a single desk to the globe. Step 1, it originates at the user device. Step 2, it travels locally to the switch. Now, if it's internal, boom, it stops there. But if it's external, it moves to step 3, the router and firewall for gateway routing and strict security inspection. And finally, step 4, it shoots out across the high-speed fiber optic telecom link. See? It's an incredibly logical step-by-step physical path.
All right, moving right along into section 4, the IT detective. This is our troubleshooting guide. Okay, now that you understand exactly how the data moves, let's shift gears and empower you with some first-line technician knowledge. This troubleshooting matrix, it's going to be your new best friend. You see, the physical geography of the network's journey dictates exactly how you solve a problem. Think about it. If the symptom is just a single desk down, you look left on our mental map. The diagnosis is localized. You check their specific device, you check their Ethernet cable, or you check their specific port on the switch. But if the symptom is the entire building going down, you look right on the map. The issue has to be at a major choke point. You need to diagnose the router, the firewall, or the main telecom fiber link entering the building. Makes sense, right? And that brings us to the ultimate golden rule takeaway for anyone experiencing the universal panic of an office internet outage. Say it with me. If only one user is complaining, check their device or switch port. But if the whole office loses connection, the issue lives at the router, firewall, or telecom link. It's quite literally all about isolating exactly where the data flow got blocked on its journey. By breaking down this massive, complex architecture into a clear, structured flow, the mystery of the corporate network totally disappears, leaving behind a logical map that you can actually navigate yourself. So I'll leave you with this provocative thought. Next time your office internet suddenly goes dark and the absolute panic sets in, will you know exactly where to look? Thanks for joining me on this explainer, and keep exploring the systems that power our world.